So Sean is asking about angle alpha. Oops. So we want to find sine and cosine for pi over 6, which is the smallest angle, pi over 4, which is the next in line, and pi over 3, which is the 60-degree angle. So here's how you easily remember this, I think. 1/2, 1/2. The square root of 3 over 2, the square root of 3 over 2. And this is the nicest. So the smallest angle has sine 1/2, and then the other one has to be the square root of 3 over 2. The largest angle is reversed. It has cosine 1/2 and the sine and the square root of 3 over 2. Any questions? Okay, so find the exact value of arc cosine -1. And then we have 3 more to go through. Let me refresh your memory a little bit about these inverse functions, the sine inverse or arc sine or arc cosine or cosine inverse. So again, back to the unit circle. Whenever you are asked to determine arc sine, you have to give an answer between -pi/2 and pi/2. That's for arc sine, between -pi/2 and pi/2. So arc sine 1/2, you have to say pi/6, which is right here. Arc sine -1/2, you have to say a -pi/6. Now coming back to arc cosine, because that's what we're asked to determine. For arc cosine, we always have to give an answer between these, between 0 and pi. So one more time for arc cosine, between 0 and pi. For arc sine, here. So then, which angle has cosine -1? And the answer has to be between 0 and pi. Perfect. Questions? Questions? Find all values of x such that sine 2x equals sine x. However, they only want between 0 and 2 pi. They don't want the infinitely many solutions. If the equation has infinitely many solutions, we don't want to determine them. We only want in one complete rotation, one from 0 to 2 pi. So my question is, first of all, what type of equation is it? Okay, I can go through a few. Okay, linear, quadratic, polynomial, rational, radical, absolute value, trig. Good, so it's a trig equation. Perfect. Now, next question. Anyone remembers what sine twice x represents? Beautiful. Thank you. Of course, I'm going to subtract sine x, and what is left on the other side? Perfect. It has to be. Good. So we replaced sine 2x by 2 sine x cosine x, and we subtracted sine x. What do you think I'm going to do next? Yes. Remember, factor and simplify always should be in the back of your mind. Always, always, always. So what do I do now then? Perfect. Excellent. So then what is left in parentheses? There is a 2 cosine x minus 1. Excellent. So then we have two options. One for sine x to be excellent, and the other one for cosine x to be 2 cosine x minus 1 equals 0, 2 cosine x equals 1, so then cosine x equals perfect. This is far from being done. We only solved the equation for sine and cosine. I mean, we solved the equation with using the zero product principle, and we got two new equations, sine x equals 0 and cosine x equals 1/2. Back to the unit circle. We measure sine on which axis? Y, very good. Where is sine 0? In a complete rotation. Yes, at 0 and pi. So sine x equals 0 means x equals 0 and x equals pi. Now we want to solve the equation cosine equals 1/2. And I have to ask myself in which quadrant is cosine positive, because I will come up with two answers. Cosine is positive where? It's measured on the x-axis. So it has to be positive here if it's measured on the x-axis. It has to be negative here if we measure it on the x-axis. Sine has to be positive here because we measure it on the y-axis, and it has to be negative here because we measure it on the y-axis. So which quadrants? Good. So now, in 104, perfect, positive here and positive here, excellent. So now remember from that little table, cosine x equals 1/2. Is it the small angle or the big angle? The big angle. So it's 60 degrees. So I divide this into 3 equal parts. So this is my angle. And then all I have to do is just draw a vertical line to find the other end, meaning the other angle, I should say, better. They have to have the same cosine. This is the piece representing 1/2, the cosine for both angles. And both angles have the same reference angle, 60 degrees, 60 degrees. My graph is not perfect, my apologies. Okay, so cosine x equals 1/2 means x equals pi over 3, and the other option is 2 pi minus pi over 3. From 2 pi, I go back. This is the reference angle, pi over 3. And this is also the reference angle, pi over 3. As you see, my measurement unit is not perfect, sorry. So 6 minus 1, 5 pi over 3. So this, 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 and this. Questions?
This is a lazy question.
Say it again?
This is a lazy question. Are we going to be doing a lot of the kind of converting double theta to? Like,
You mean the identities?
yes.
Yeah, some of the identities are important, yes. So I'll tell you which. Yeah. Some of the trig identities. Okay, two more. Okay, we have y equals sine x minus pi over 2. We're asked to graph this without using a calculator, fine. So what is the base function or core function that was used here? Well, obviously I only see one function, which is sine x. So then I know how to graph sine x. 0, pi over 2, pi, 3 pi over 2, and 2 pi. 1 period. What is the value of sine at 0?
0,
Perfect. At pi over 2?
1,
At pi?
0,
At 3 pi over 2? And at 2 pi?
0.
Perfect. So here's the graph of sine. What does this do to the graph of sine? It shifts the graph. Where? Which direction?
Right.
To the right. How much?
5 over 2.
Right. So instead of starting here, it starts here. This is the graph of sine x minus pi over 2. And the last one, arc sine of sine 3 pi over 2. Before you say anything about this, I want to say something about this. If I have a function and I apply it to the inverse function, or I have an inverse function and I apply it to the function itself, what do I always get? Excellent. This is the property of inverse functions. What does this mean? For example, I give you $10 and 3 minutes later I say give it back to me. No deal, right? Nothing happened. You did not get $10 and you didn't lose $10. Nothing changed in your pocket. I'm giving you 10, I ask for 10 back. Why? Because addition by 10 and subtraction by 10 are inverse operations. That's why the result is still x. The same thing here. And I know that arcsine and sine are inverse functions. And because they're inverse functions and because of the property of inverse functions, I am tempted to blindly write 3 pi over 2. Wrong. And you can say, wait a minute, you just presented this and then you're saying, yes, here's the situation. As I mentioned a few minutes ago, the answer, if the answer for arcsine is not an angle, forgive me, is if it's not an angle between negative pi over 2 and pi over 2 and 3 pi over 2 is, you can say, but it's this. Yes, but I cannot write it as 3 pi over 2. I have to write it as negative pi over 2. But because that's the point, you can say it's the same point, but no, I can't do that. So I cannot, in this situation, I cannot blindly write 3 pi over 2. Can I still evaluate this? Of course. Of course I can. But the answer will not be 3 pi over 2, meaning for this particular situation, because of the restrictions we have on the inverse functions, otherwise on the function itself, because otherwise we will not be able to create the inverse function. So for example, coming back here for a second, look at sine. Is sine 1-to-1? No, it's not. It's not 1-to-1 because if you cross it with a y, with a horizontal line, you will see it's not 1-to-1. So this function doesn't have an inverse. The function that is not 1-to-1, for example, does this function have an inverse function? No, because it's not one-to-one. But no, it does. I truncated the domain. I minimized the domain. Now this piece is one-to-one. So that's why, in order to invent the inverse function for sine, they said, okay, we are going to consider for sine just this piece. Because that piece alone, only between negative pi and pi, but negative pi over 2 and pi over 2 is one-to-one. Now I can create the inverse function, but not on the entire function. So that's why we have to get an answer between negative pi over 2 and pi over 2. Between negative pi over 2 and pi over 2. So therefore, we can still determine this, but we have to take it piece by piece. So arc sine. How much is sine 3 pi over 2? And now the answer is, and it has to be between negative pi over 2 and pi over 2, and the answer is negative pi over 2. Now, you understand how important this is, because this is false, in a way. Because I'm telling you that you can determine sine of 500 degrees, which is wrong. You can, because sine is a periodic function. But because if we don't truncate the domain and say this function only exists for the purpose of the inverse only, between negative pi over 2 and pi over 2, it's not one-to-one, and I can create an inverse function. Okay?
In the instances of questions asking about inverse trigonometric function, is that always going to be assumed that you're truncating?
Absolutely. Yeah. For example, for tangent, since we talked about that, I want to refresh your memory on tangent, the graph of tangent and the graph of the inverse tangent. So look at tangent. Here's tangent. Is this function one-to-one? No. No, it's not one-to-one. But now it is.
So it's not one because it would.
By the horizontal line test. But now it is. So we diminished or we say truncated its domain between negative pi over 2 and pi over 2 open. So now it is. So the domain, so when you determine arc tangent, the answer must be somewhere between negative pi over 2 and pi over 2. This is out.
Arc tangent was.
Yes, yes. And the arc tangent has horizontal asymptotes. This is y equals negative pi over 2. This is y equals pi over 2. And this is arc tangent. This one had vertical asymptote at negative pi over 2 and pi over 2. This one must have horizontal asymptotes at negative pi over 2, pi over 2. That was a crash course in pre-calculus in 3 hours. Let me know if you encounter anything with that website, with WebAssign, etc., etc. Any questions before we start? Any questions? Okay. Now, at least for a while, this function will become our best friend. And this figure, now, of course, our P and our Q, nothing new. So the x-coordinate of P is again x. The x-coordinate of Q is again x plus h. This is, of course, f of x. This is, of course, f of x plus h. And here's our question here in this problem. At least estimate, if not find, at least estimate the slope of the tangent line at P. We're going to work with examples in a moment, but I want to explain what we're trying to do. For now, let's assume that P and Q are not close. Let's assume. Let's assume that this is not x plus h, but it's whatever else. Okay, for a second. How do I determine the slope of the tangent line at this point? From algebra, I know that I have to be given two ordered pairs, right, to determine the slope of a line. But I only have one point. I only have P. So we're going to do this. We're going to draw the secant line PQ. And we're going to determine the slope of the secant line that we just determined a few minutes ago. What is the slope of the secant line PQ? Yes, of course, it's a difference quotient. What is it? Plus h minus f of x divided by h. Again, we are going to pick a function in a minute, and we're going to work through the example step by step. But stay with me for 1 second. Now let's say that I move Q here. I create the slope of this line. I determine the slope of this line. Will the slope of the red line be somewhat closer to the slope of the tangent line than the initial PQ?
Yes.
Okay. Let's say now I get even closer. I'm here. Do you think that the slope of the third line will be closer to the slope of the tangent line than the previous two? Okay, and now finally, P and Q will never be the same point. I cannot say now that Q is here because H is not 0. You can say that H approaches 0, but you cannot say that H equals 0. Okay, so P and Q will never be the same. So is it clear that as closer I get to with Q to P, the slope of the next line and the next line and the next line will be even closer to the slope of the tangent line at P? What will the tangent line at P give us? The slope of the tangent line at P. What will it mean? The slope of the tangent at P will mean the rate of change of the function at that point, like the instantaneous velocity when you call me and say, look at your odometer, how much is it? What does it say? So the slope of the tangent line at P is the same with the rate of change, the instantaneous. It can be velocity too. I'll put in parentheses. The instantaneous rate of change at P. And it equals something else, but I can't say it just yet.
What does the M stand for?
Say it again.
The M stand for M.
The slope.
Okay.
So the slope of the tangent line at P, that's the slope of the tangent line at P, is the same with the instantaneous. It could be velocity if the function is the distance, rate of change at P, or the velocity at P at that particular instant. Okay, so we are ready to look at a problem. I'll let you choose. We want to illustrate with numbers first to see what it means. Anything you want, I can recommend. I recommend 3 or 4. I do recommend 5 or 6. We can do 8.
How about 4?
What about 4? Let's do it. Let's look at 4. Let's read 4 first. We are given a point. This is my P, x comma f of x. It lies on the curve cosine pi x. If Q is the point, of course, x comma f of pi x, use your calculator to find the slope of the secant line PQ, correct to 6 decimal places, which is the average rate of change in this case, for the following values of x. I'm going to copy them in the correct order, not the way they throw them at us. Using the results of part A, guess the value of the slope of the tangent line to the curve. Using the slope from part B, find the equation of the tangent line and then sketch the curve 2 of the secant lines. We can do that with a calculator. Oh, sorry, right away. Okay, perfect. So let's start. Something fell behind me, yes. Okay, so this is problem 4 on page 86. We're given point P, 0.5 comma 0, and we are given y, cosine pi x. We are given point Q, of course x, cosine pi x, and we are given some points, some x values, and we are going to build a table. The slope PQ and careful how we put them in. Look at the numbers: 0, 0.4, 0.49, 0.499, 1, 0.6, 0.51, 0.501. So obviously we're talking about P. So 0.5 will be in the middle, everything else to the left and to the right, in the correct order. So the smallest number is 0. Then I continue with 0.4. Then I continue with 0.49. Then I continue with 0.499, but then I continue with 0.501, and then with 0.51, and then with 0.6, and then with 0.1. That's the correct order. Okay? Good. So let's put them in. So then I have 0. Let's see how I run out of room this time. 0, 0.4, 0.499. I jumped, of course. So this is 0.4 and then 0.49. It's not that important, but I want to put them in the correct order. You'll see why it's not that important in a minute. 0.499. 0.5 is in the middle. And then the next one on the other side is 0.501. And then 0.51. And then 0.6. And then 1. And I'm going to copy the beginning of the table. But you know this should have been on continued. Okay, ready? Forget about the numbers. I really don't care about them. I care about the function. So this is a function in which I have point P, and I have point Q. Point P is 0.5 comma 0, and point Q is x comma cosine pi x. I would like you to give me the equation or the expression of the slope PQ. Look carefully and tell me what to write. This is what you should look at. This does not mean anything.
So 0.
Y2 minus y1 over x2 minus x1. So cosine pi x minus, yes, let's write it for everyone to see, over,
X minus
that's it. This is what we are going to plug in the graphing calculator. Of course, without the 0, there is no need. So let's plug it in. Ready? In y equals, please erase, delete if you have anything in there. It's a rational function. I know it only has one term at the top, but if it had two, we would have had to put parentheses. So in order to make sure that it's clear to you, I'm going to put parentheses. I have pi x, close the parenthesis for inside cosine, close the parenthesis for the outside cosine, and we divide absolutely in parentheses x minus 0.5. After that, after we put it in, please go to second and table set. And make sure your independent variable is in the ask mode. Only the independent. And then let's go to second and table. In order from left to right, from the smallest to the largest, I put in 0. By the way, I want to put in 0.5.
would not fit with that.
I want to put in 0.5. What do you say?
No.
Of course not. Why?
The break that.
Thank you. I'll tell Susan you said that. Excellent. You will absolutely break math. Very good. From left to right, 0, enter, 0.4, enter. Oops, I 0.4, enter. 0.49, 0.499. 0.501, 0.51, 0.6, and 1. These are the numbers. Could I have repeated the operation 10 million times? Yes, but I didn't want to do that. I put in the function and I plugged it in. So we will copy these numbers. So this is -2 and then -3.09, -3.141, -3.142, -3.142, -3.141, -3.09, and -2. Okay, I copied them. I don't really care about any of those. I just want something very close to 0.5. So I'm going to say 0.5, 0.000000001. Just give me the slope of the tangent line at 0.5. Because I brought right now Q so close to P that is really, bless you, the slope of the tangent line. So can anyone guess then? What is the slope of the tangent line at P? What is it? What happens if I put in 0.5? You already told me. But I didn't put in 0.5. I put in a number from one of the sides, it doesn't matter which one, so close to 0.5 that the calculator actually gave me the slope of the tangent line at that point. Now we're also asked to determine the equation of the line, having the point and the slope. Let's do that. So y minus y1 equals the slope times x minus x1, in which the slope is -3, and then we have 0.5 and 0.
What was the question that we're determining?
The slope of the equation of the tangent line now. So we determine the slope, we have the point, and we use the point slope form to find the actual equation of the tangent line to the graph of the function cosine pi x at p. Is that okay? So this is 0, so then I have y equals -3 x minus 0.5. I will distribute and get y equals -3x plus 1.5. They're asking us now to go back and graph, they say, sketch the curve, 2 of the secant lines and the tangent line. I'm going to sketch the curve and the tangent line. And we can, bless you, we can come up with an equation of another secant line. Of a secant line. So in y equals, I have to clear everything. Maybe not everything, I just need the function in there, basically. Okay, and now I'm going to put the equation of the tangent line, which is -3x, and then plus 1.5. And I only want the action to be shown around 0.5, right? So I'm going to change the viewing window and say I only care about, let's say, -2 to 2. And with a scale of 1, between -2 and 4. Oops, that's not what I meant. -2 and 4. Oops. Four. Okay, ready? Careful, there will be 2 colors, blue and red. Blue is the function in that area, and then the tangent. Ready? Thank you. Let's see what I did. What did I do? Ah, I know what I didn't like. Thank you. Okay, are you happy now? Here's the blue. We only care about here at 0.5. Around here, somewhere at 0.5. Ah, it's coming. That's it. The slope of -3 and crossing the x-axis at 1.5. And here is the tangent line at 0.5, 0, right here. Okay, so -3.5, and the y-intercept is 1.5. And when x is 0, is 1.5. When y is 0, is 0.5. So right here. Any questions? Any questions? We did not graph a secant line. I can, but I have to use any of these slopes. So we can. Oops. So we can graph the, but we have to use any slope. So let's use this slope, a -2. So we have cosine 1 times pi, which is -1, -2. That's the point. Right? Because we are going to have this point and that point, or the slope. I already have the slope and the point. So let's do that. So it's y minus 0 again equals the slope, which is -2, and x minus 0.5.
We're finding the tangent line.
No, I'm finding the equation of any secant line. We already found the tangent. This is the tangent. This is the equation of the tangent line at P. But the problem was asking us to put in not just the graph of the function and the tangent at P, but also a secant line. They wanted us to graph a secant line. So I used the point and a new slope, which is -2. So this will be y equals -2x and +1. So I'll put it in as the third function so we can see it. It has to pass through P, of course, because we use that to determine the slope. So this is -2x + 1. Careful. Here it comes. That's it. So that's a secant line that has to go through P, but goes through these points. That point was 0, 1, was it? When x is 1. Yeah. With a slope of -2. Any questions?
Can you review how you got the slope for the secant line again? The -2. Or the
It's right here. All these are slopes.
Okay.
And I just picked this point because it was the easiest. I was lazy. I didn't want to plug in -3.09 or -3.141, so I chose that one.
Okay.
Yep. Okay, so I chose this point with a slope of -1, a -2,
Okay.
to determine a secant line, any secant line. So this is a secant line. Secant PQ. Where P is the same, but the x-coordinate of P is 1. The x-coordinate of Q is 1.
And you just picked a random x.
No. X is 1.
Okay.
X is 1, and the slope is -2. I picked a random secant from all those, the one with the easiest slope. Questions? Is this clear? Do we need another example? We understand what happened or what we did here, or any questions? Any questions? Anything?
I guess need more time to marinate on the homework.
I guess could you
Yes.
explain what we did here and like why that matters, like what we're finding?
Right. So we're interested in determining the rate of change of this function at point P. And we were not able to determine that without having 2 points. I can't determine the slope of a line if I don't have 2 points. So I determined the slope of a secant line. And once I determine the slope of this secant line, in order to determine the exact rate of change here, I said, okay, let me bring this point closer. Let's determine the slope of the secant line. And let me move Q even closer to P. Let's determine the slope of this line. So these are all these numbers that we just determined. So this number is between point Q, which is 0, comma cosine 0, and P, and the slope is -2. Now this is the slope of the line going through P and through 0.5 cosine pi times 0.5. And I got this slope. The next one is the slope of the secant line between 0.5 and 0 and 0.49 and cosine pi times 0.49. And I got this slope. So in this way, I'm bringing Q from 0 with numbers smaller than 0.5, from 0 with numbers smaller than 0.5, as close as possible to 0.5. Now on the other side, I can also consider the right-hand side. I'm coming from 1 closer and closer, closer and closer to 0.5. So I determine this slope, I determine this slope, I determine this slope, I determine this slope. And in both directions, the answer was closer and closer to -3. So one more time. It's a very good question. So here is P, and here's Q. I need to determine the slope of this line, then the slope of this line, then the slope of this line, then the slope of this line, till it gets so close that I can read the slope of this line. And the slope of the tangent line at P happens to be -3. So if you ask me, what is the rate of change of distance with respect to time of a particle that moves along this curve exactly at the point 0 when x is 0 and y is 0.5, I will say is -3 feet per second. If you ask me what is the average rate of change between P and Q, and let's say Q is at 1, then I will say the rate of change, this rate of change is the slope and is -2. If you move Q here, let's say at 0.6, this is 0.6. Now I'll tell you the slope between these two is -3.01. This slope is -3.09.
So for this example, our curve would be oriented different.
Of course.
Right.
Of course, because it's all negative. Of course. Absolutely. I was just explaining without even thinking of graphing anything exact. Is this better? Yes, everyone?
So you would use equation to find the equation of a tangent line for instantaneous, and then the average rate of change would be the secant.
The slope of the secant line. The slope of the secant line is the average rate of change. The slope of the tangent line is the instantaneous rate of change at a point. So this line gives us the rate of change, the average rate of change between P and Q. This line here gives us the rate of change, the instantaneous rate of change at P. And that's why we brought Q closer and closer to P from either side. So we came from 1 to 0.4, and also from 1 to 0.5, and also from 0 to 0.5. We came in closer and closer, and we got the same answer, -3. Is this better? I know we only have 4 minutes left. I would have done one more problem, and we can you can look at what we covered today, and we can work on another problem on Monday. Which part was confusing that I should address? Maybe on a different problem next time.
The -3 is just an approximation of pi, right? Because I'm getting -pi.
You're getting -pi for
approaching 0.5.
from either side. Oh, I don't have the slope here anymore. I have to create the slope. I don't have the slope anymore. No, I can write it again. I can put it in. And I can even